Assalamualaikum warahmatullahi wabarakatuh and good day. Today we will continue our lecture about numerical differentiation, our chapter 4 here. We're still in chapter 4. In the previous video, you have looked about, or we already discussed about, how can we obtain the first derivative and also the second derivative by numerical formula, and all the formula is given for you. The only thing that you need to know is to choose the correct formula that is provided or that is given for you, and then after that you just apply whatever you have in your table of data. So today for the third derivative, it is also same. This is the formula that is available for the third derivative, but I'm not sure because I've taken a look in your table of formula or list of formula that will be given for you in the exam, but there is no third derivative formula in that list of formula. But never mind. At least if we give you the formula, and then after that the only thing that you need to know is you apply the formula. Okay, so for this example, what you have a function, this one, x sine x, and you also given all the value of the function of x at 5 different points. 0.5 here, the value is 0.2397 and so on. And then after that you need to find the third derivative by using formula, and then at the point x equal to 1.5. So now let's say we want to use the central difference to find the third derivative. So the second one here, let's say we will use this formula. So at this point, or I think for this example, let's say you are given 5 points, the value of that function at 5 points. Of course, the only formula that you can use is central difference, because we need to find the third derivative at this point, and we have 2 value here and 2 value at the back. And if you see all the formula here, we need to have fx3 plus h, so meaning that we don't have this value fx3 plus h, we don't have, so that we cannot use it. And then but for the central difference, here we have this, and this, all the value is given for us. And it is also for the backward difference, it is the same case for the forward difference, because here you see we don't have what is the value of that function if you look backward 3 points. Okay, so we cannot use, the only formula that we can use is the central difference. And so now we want to use that formula, and we see here our h, or our grid spacing h is equal to 0.5, because the difference between first x 0.5 and 1 and all that point is 0.5. So that what we want to find is the third derivative at the point 1.5. So you can apply the formula. Of course, the first formula is fx plus 2h, and what you will get is f 2.5, and then minus 2 multiplied by f 2.0 plus 2 f 1.0, and then minus f 0.5 divided by 2h cubed, 2 multiplied by 0.5 cube. And at all this point, you have what is the value of that function. So you just substitute. Here the value is 1.4962 minus 2 multiplied by 1.8186 plus 2 multiplied by 0.8415. Here minus 0.2397, and then divide by that value to 0.5 cube, and then after that you can calculate, and what you will get, I think, is minus 2.7908, and this is the value that you obtain by numerical formula. And we can calculate the error. So to calculate the error, what you need to do is you need to find first the third derivative of your function fx. But of course, to find the third derivative, what you must find first, if you have a function fx is equal to x sine x actually, and then first you need to find the first derivative. It is x cos x plus sine x, and then you need to find what is the second derivative, x negative sine x, and then plus cos x plus cos x. And so now your third derivative is minus x cos x and minus sine x minus sine x minus sine x. So you will get minus x cos x minus 3 sine x, and the exact value of the third derivative at point 1.5 is equal to, you just substitute when your x is equal to 1.5, cos 1.5 minus 3 sine 1.5, and if you use the calculator, what you will get is minus 3.0986, the exact value of the third derivative at point 1.5. And don't forget with your mod, when you calculate what is the cos 1.5 sine 1.5 here. So meaning that the absolute error is equal to absolute negative 3.09 minus negative 3.0986. Oh, no. It is negative 2.7908, and what you will get is 0.2 3078, the absolute error. So it's quite a big error, but never mind, at least you need to know how to apply the formula. And then we go to the next example, and I think this is a good example in this chapter because it's a combination between the chapter 3, where you learn about interpolation, where you have Newton divided difference, and then we also ask you about to estimate what is the value of your function at point 2.5 and 6.4. So for here you must know a little bit about Newton divided difference, and we also ask you to estimate what is the value of first derivative at point 2, second derivative at x when x equal to 3, so meaning that we need to find your polynomial function first by using your knowledge in interpolation, so by using Newton divided difference, and then after that you can find the polynomial, what is the polynomial or the function that you will get, and then after that you can estimate the first derivative and also the second derivative. So that if you still remember, or you also can take a look in your table of formula for the Newton divided difference. If you have a function like this, the Newton divided difference, the formula for Newton divided difference is Px, this is a polynomial that we want to get, is f naught plus f naught 1 x minus x naught plus f naught 2 at the second x minus x naught x minus x1 plus dot 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 and so on, and last plus f naught n x minus x naught multiplied by x minus x1 and so on multiplied by x minus x n minus 1. So this is the formula for Newton divided difference to get. So the first question, complete the above table. So meaning that we need to find what is the value of A here, B here, and C here. And the first step, of course, we know that this value, the one value here that we will get from these two value here divided by the difference between all these x minus 2. So to get what is C first, is what you can do is 17 minus C to get the value of 1. 17 minus C divided by x minus 2 is equal to 1. And if you do the simplification, if you do the algebra, what you will get is C is equal to 11. So that now we have the value of C equal to 11. And then after that, you can also get what is the value of b by using, when your c here is equal to 11, and then after that maybe you can use b minus 22 here is divided by 6 minus 2 is equal to 11. So to write, so maybe you can write b minus 22 divided by 6 minus 2 is equal to 11. And if you do the algebra, what you will get is your b is 66. In fact, here you also can use 151 here. This value minus b is equal to 17. In fact, so you can try 151 minus b, but of course it is 8 minus 3. 8 minus 3 is equal to 17. And if you do your algebra, this simple algebra, you will get b also is equal to 66. So at the same time, you also study about the interpolation. And of course, to get a, you can use this value 234 minus a and divide by 6 minus 3 is equal to 66, because we know what is the value of b. And we also can use a minus 14 divided by 3 minus 2 is equal to 22. So either way, and here maybe you can use a minus 14 divided by 3 minus 2 is equal to 22, and this implies your a is equal to 36. Alternatively, you can, or as I said, you can use 234 minus a divided by 6 minus 3 is equal to our value of b 66, and then after that you do your this calculation, and then you will get a is equal to 36. It is same. And then after that you can calculate the polynomial. The polynomial is px. You can substitute all the value into the formula plus f1 1 x minus x naught, and then plus f naught 2 x minus x naught x minus x1, and we have up to 3 f 3 level 3, and then x minus x naught x minus x1 x minus x2, and then after that you have all the value. F naught is equal to 14 plus f naught 1 is equal to 66 x minus 2, and then plus f naught 2, if you calculate you will get 11 x minus 2 x minus 3, and f naught 3 is 1 here, and then so here you will have x minus your x naught is equal to 2 x minus 3 x minus 6, and this is the I think this is the polynomial that you will get. I think you don't need to simplify. And next, this is, I think this is a question for 2, and for 3 you need to estimate what is the value of function when x is equal to 2.5 also is equal to P or not equal to approximate for this polynomial when x equal to 2.5, and then you just substitute what is the value of when the value of x in your polynomial equal to 2.5, you will get 23.125. And you also need to calculate what is the value when x equal to 6.4, approximate P 6.4, and then what you will get is 281.344. So this is what you already learned in the previous chapter, and then hence estimate f prime 2. So here, so when x is equal to 2, this one, and you have so many formula in the first derivative, but we need to choose the correct one, and you also have f 2.5 here that you already calculated, so that the only possible formula is you can use is 2-point forward difference. So we use 2-point forward difference formula. Implies that f prime 2 is equal to f 2.5 minus f2 divided by 0.5, and then you will get the answer. What is the answer? And also same for the case of second derivative is equal to what, and for the case of second derivative at when x is equal to 3, and for this one, I think for the second derivative, the only possible formula is 3-point. Use 3-point backward. Formula. What I can say is you need to use all the I know that if you, let's say you want to use for the first derivative here, you use the forward difference. Maybe some of you will ask why we don't use the 2-point backward difference, for example, or central difference. Yep, but I think the best answer is you need to use what you have so far, because here in the third question here, you also asked to find f 2.5, f 6.4. I know that you can find what is the value of 1.5 and so on, but that is no purpose for the question number 3. You need to find what is the value of 2.5. Okay, so this is about our combination between interpolation and also derivative. And then the next, we also can ask you about fourth order derivative or fourth derivative by numerical, and it is the same. You just need to apply the correct formula. and I think there is no problem for you to do this one, because this is just apply the formula. So this is the formula. We have you can see we have three formula for fourth derivative. And if I look at the table of formula or list of formula, for the fourth order you only have one formula that is given for you, which is 5 points fourth order centered difference formula, which is this one. Unless we change the formula, and then you can use either one. Okay, so for this one, I think it is same. You have the function x sin x, and then after that you need to find what is the value for the fourth derivative when x equal to 1.5 here. So we have two values, 1 and 2, backward, and we also have 2 values for your function at 2 point forward, so that we can apply the central difference, because we have all this value of function. And for the fourth derivative, I think I don't need to do, because it's the same step. But for this one, the answer is when you calculate the fourth order, the answer is f fourth when x is equal to 1.5, you will get 1.1632, and the absolute error is equal to 0.05, not 1. Okay, alright. So I think it is all about chapter 4, numerical differentiation. You only need to apply the formula, or you also can take a look in the previous sample past year, sample final exam question. We also can combine the problem with the Newton divided difference, or Newton backward, Newton forward, and then after that we can ask you to find what is the value of that function, and then after that you just apply the formula. Okay, so we have done our chapter 4. This is a very short, very small chapter about numerical differentiation. Okay, I leave the example 7 here, maybe for you to do. No need to do exercise, because this is just a simple one. Okay, see you next time in the next video. Thank you very much, and I think that's all for today. Thank you very much, and Assalamualaikum warahmatullahi wabarakatuh.